Thanks, Pete, for that welcome, and thanks, everybody. I want to welcome you here today. It's great to be here. It's great to be your host today as we present ArcGIS 2023, our system and its capabilities. Now, our vision for ArcGIS is that it's a comprehensive geospatial system that supports multiple communities. Many of us here today are part of the GIS professional community. It's our biggest and most established group of users. But today, GIS has always been about spatial analysis, and today we serve the broader data science and analytics community with access to those powerful tools and techniques. The imagery community is growing rapidly, driven in part by the ease of access to data and data collection techniques, which is fueling reality capture, and we're going to look at some of that this morning as well. And then there are those of you who are drawing in location services and developing your own applications. Well, today, everything that we have, all of our capabilities, our tools, our data and content is all available to you via an API through ArcGIS platform. But I think what's really exciting is that you, in these communities, are not isolated. But what we're seeing is that you're interacting and you're working together, increasingly serving the public and wider society with access to geography in decision-making. And our role at Esri, our mission, is to provide you with world-class tools and technology to allow you to do that. And we also see our mission as continuing to lower the barrier for entry and provide these approaches to a wider group of people. So ArcGIS is relevant to all of these different communities and contexts, and to support that, it works with all types of data. Now, why is that important? Because it creates an environment for us to come together from all of these different places and participate in a bigger story using the power of location. You see, geography works like an index between systems. If I want to know how the information in one system relates to another, location is one of the most powerful keys or references that we have that can bridge these systems. And so in this whole community, we're in this unique position where the technology that we have access to is not only ideally suited to model the natural and the built environments of our world, but also to bridge them together. And that is something that is unique to GIS amongst all the different information technology platforms that you can go and find. So today, I would like to ask you a question. What is it that you or your organization is doing with GIS? I mean, if you abstract it, what are you actually doing? Here's what I think. You're using software to represent something in the real world. You're bringing together data and information to create context. You're performing some kind of analysis or modeling to create new learning. And then you're using that learning to make a decision in the real world. What you're doing is building and operating digital twins of our world, digital twins of the natural and the built environment. Now, you might be doing this directly. Perhaps you're a GIS analyst who is driving the software, performing analysis, and providing information to decision makers. Or maybe you're managing a real-time system that's being constantly updated with real-time information flows, and your role is to make sense of that and make some decisions off the back of it. Or perhaps your job is to train an AI to constantly evaluate the changing nature of that real-time system, to spot patterns and trends, maybe even make predictions or start to take actions to resolve situations. You see, each of those scenarios that I've just mentioned is a digital twin. And I actually find the digital twin terminology, the language, really helpful to describe what it is that I'm doing with GIS and articulate the value of that to the people that I'm speaking with. But I've also found that in some circumstances, in some contexts, for some audiences, digital twin has very specific meanings, and it's not always the same. So I find it helpful to think of digital twin not as one thing, but as a maturity index, which encapsulates all of this scope that I've been speaking about, but it addresses the needs of different audiences, and it ascribes value to what it is that they're doing within the digital twin spectrum. So let me take you through it. At the base level, it's about capturing and collating information. And that information, that data, is a representation of something within the real world that holds value. So we have this foundational capture level of maturity. From here, I want to visualize the data that I have and see it in the context of the natural and the built environment. I need to bring together data from different sources to provide that context so that I can see what I have in the context of everything else that there already is, the visual level of maturity. Next, I want to start asking questions. I want to interrogate my digital twin. I need to use spatial analysis techniques to get those answers, the analytical level of maturity. Okay, but up until this point, my digital twin is static. All of the information that I've captured, visualized, and analyzed represents a snapshot in time. But actually, that's perfect in many situations. Lots of you here today are managing geospatial systems that don't change rapidly, and there's lots of value in that. But if your system does change, you're going to need a way to take account of real-time information in your modeling. But who's making decisions in a scenario like this? Is it a human, for example, managing the changing nature of a transport network, looking at all of the things that are happening and making decisions on that real-time system? Or could I train an AI? Could I use an algorithm to evaluate that system, to spot patterns and trends, to reduce bottlenecks in the network, prevent congestion, and dispatch emergency services and respond to other incidents? In this situation, the environment starts to take decisions, maybe to preserve the health of the system. Could it prevent collisions? Could it optimize, learn, grow? This is what I'd call a semi-autonomous level of maturity. And where do we go from here? Well, let's extrapolate what we have. More decisions are made autonomously. The system learns, optimizes, it self-heals. Lots of data begins to be brought together from different sources. Imagine an environment that genuinely models our world. And it brings together data from multiple agencies, from natural and built environments, from rivers to roads, buildings, from habitats to forestry, energy, transport networks, real-time weather, and traffic. And the system knows and understands all of the relationships and interactions between the different data and subsystems within it. It knows how a change in one area affects another area. It's able to learn, to optimize, and to take decisions. It's a fully living, breathing, autonomous digital twin. Now, I actually think that this level of maturity, if you like, is almost a scale in its own right. There's clearly lots still to do here. But the reality is that technology that we make at Esri is being used by you every day to make some of this real. You in this room and watching online are the custodians of all of that data that I've just spoken about, and much, much more. You're the stakeholders in modeling the natural and the built environments of our world and using them to make decisions about the future of our planet. And at Esri, we're not alone in recognizing that digital twin is not a one-size-fits-all concept. Actually, if you start to look at some particular sectors and industries, professional associations, you'll see similar themes emerging. So I hope that you find this helpful. I find this really helpful in articulating, what it is that you're doing with GIS, particularly when you're speaking to non-GIS audiences. Now, earlier I said that our mission at Esri is to provide you with the tools and the technology to help you do the important work that you do. And when we're building digital twins of the world, a part of it is about bringing together disparate data sets and making sense of them. And so one of the ways that we help with this at Esri is we build the Living Atlas of the world. We curate the Living Atlas, which is the world's largest collection of geographic information. It's things like maps, demographic information, near real-time data sets. It's authoritative data and content from us at Esri, from our partners, from the organizations that you represent, and from the wider community. And it's not just data. It's also spatial analysis tools, machine learning models, and other analytics that you can plug into and use directly. And so this is a great time for me to introduce you to Finn. Finn Ryley is a content services consultant who's working in our localization team. And Finn's been doing some great work to bring to life the visual digital twin using the power of the Living Atlas. Let's take a look, Finn.
Thanks, Mark. Here at Esri, we are creating our very own GIS of the world, a living atlas of the planet, a geospatial nervous system, if you will, key for creating digital twins for a more sustainable future. Central to the ArcGIS system, Living Atlas contains a wealth of content across so many different themes, from base maps to transportation systems, imagery to administrative areas. Each item has been handpicked, minimizing the data management burden and maximizing time for your analysis. Did you know there are over 10,000 authoritative data sets in Living Atlas, with over 600 of those specific to the UK? In the next 10 minutes, I'm going to show you just 3 of these demonstrations, 3 of these content themes, and demonstrate how easily Living Atlas can benefit digital twins. Firstly, let me show you how easy it is for you to do this. Now, I enjoy cycling and traveling to different cities in the UK, and I'm thinking of taking a trip to Bristol. So I'm going to make a map of the city centre, just to get an idea of what's going on here. First of all, I'm going to add in some vegetation. Now, you see here, the Environment Agency have published their vegetation object model. This was sampled using LiDAR data as part of the Keeping Rivers Cool project. Now, when I add this to my map, you'll notice that the lighter data blocks out my base map. But I can use a really easy blending tool just to remove those lighter areas. Next, I want to see what the traffic is doing in the area. I can see this using the World Traffic Service, which updates every 5 minutes globally. Not only can I see the traffic in the area, but I can also see any live instance going on. It's not as busy as it was at the weekend. There's lots of traffic. Now, I want to add some buildings to get some context for the area. And I can do that using the OpenStreetMap buildings layer. Now, you notice that when I add this to my map, these buildings come pre-styled based on the building type. However, for the purpose of my map, I'm just going to change the symbology of these to gray. Now, I mentioned I'm a cyclist, and so if I was to cycle to Bristol, it would be useful to know where I can park my bike. Using the OpenStreetMap amenities layer, I can find this information out. Again, you'll notice that when I add this data set, there's loads and loads of other information that I don't particularly need for the purpose of my map. So using a really easy filter, I can filter out the information I don't need just to retain the bicycle parking. Great. So I've got my map. I can see where I can park my bike, and I can see the traffic, which is actually not too bad. I can really bring this to life in 3D using the scene viewer. What's more is that I can use the sun and shade tools to really get a sense of the area. Now, say I was planning a trip further afield and wanted to head up to a different city. Because I've already made my map and added in the data sets that I'm curious about, I could easily head over to Manchester, for example. What's more is that the scene viewer's got some weather tools. So let's make it rain. Now, the OpenStreetMap data sets are global. So if I was planning an even longer trip and I wanted to head over to Paris, I can quickly hop over and see what the traffic is doing around the Arc de Triomphe. Looking back at the UK, Living Atlas contains such a wealth of content, providing you a platform to publish your own organizational data. Back in 2021, Many of you in England and Wales may remember completing the Office of National Statistics census. Spatial by Design, we have published this to Living Atlas, covering 6 themes and over 550 attribute fields. So it's great having all of this authoritative, curated information at your fingertips, but what insight can we draw from this? What can we actually do with this data? Take a flooding scenario in the UK, for example. How could we use this ONS data and other information in Living Atlas to identify communities most at risk? Using ArcGIS story maps and the Living Atlas datasets, I'm going to show you how. To identify the communities most at risk, I've first mapped single-family households aged over 66. You can see the increasing rate from light to dark blue. Now, of course, households under 66 will also be affected, but not evenly. To identify these areas, I've mapped the rate of multiple deprivation in 4 dimensions. These dimensions are indexes of multiple deprivation, including health, housing, education, and employment. Using visualization tools in the ArcGIS system and applying a bivariate symbology, I can still see the rate of households over 66 in blue, as well as the areas most deprived in yellow. I can now also see where these 2 areas overlap in black. Focusing on Eastbourne, I can see there are 2 neighborhoods with communities potentially most at risk. By adding in the flood alert data from Living Atlas, I can now identify specific households in the area who may benefit from support most during a flood event. Having all of this curated information so specific to demographics in Living Atlas is incredible. But what about beyond the UK? What about the other 9,000 datasets in Living Atlas, many of which with a worldwide extent? Taking the perspective of a humanitarian organization, I'm going to look at some disaster mitigation and see how earthquakes can be monitored for a future scenario. Earlier this year, there was a devastating earthquake in the Syria-Turkey region. Less than 2 weeks ago, I'm also able to see the magnitude of an event that occurred by using the recent earthquakes in Living Atlas. Here we can see the magnitude, as well as the shake intensity of this event. Using the Global Earthquake Archive, I'm also able to see how active the region is. We can see over the last 50 years, there's been a huge amount of earthquakes. Of critical first importance is understanding where the people are, where are the settlements, and where are the built-up areas. Focusing in on Gaziantep, a city that was recently impacted earlier this year, we can start to get a picture of these built-up areas using regularly updated Sentinel-2 satellite imagery from Living Atlas. What's more is that I can identify these settlements using the Human Settlements Classification deep learning model in Living Atlas. One step further is we have already published this information for you in the Human Settlements Global Dataset in Living Atlas. This also contains loads of attribute information to assist humanitarian aid, such as population statistics, flooding, and so much more. Now, I know where my settlements are globally, as well as some population information, and also the size of the city. And I also know where earthquakes have occurred using the Global Earthquake Archive. To identify the cities most at risk, I've created a density layer from this Global Earthquake Archive using spatial analysis tools in the ArcGIS system. By combining this with the settlement data, I've been able to identify and rank that 4 of the top 10 cities globally are in northern Pakistan. So as a disaster mitigation organization, I could use this information to better plan resource to prepare for a future earthquake scenario. The demonstrations I've shown you today wouldn't have been possible if it weren't for the fantastic contributions across the GIS community. And from that, we've been able to get straight to the answers without needing to source, process, and maintain the data. With an ArcGIS Online subscription, all of this information and data is ready for you to use and integrate in your organization right now. Do you also publish data? Why not speak to us and make it available in Living Atlas? Today, I've showcased just a handful of what you can do with Living Atlas, but but it really is just the tip of the iceberg, ready for you all to use and leverage and start building your very own visual digital twins. Thank you very much. Mark, back to you.
Thanks, Finn. Great introduction there to the visual digital twin powered by the Living Atlas. And as Finn said, if you've got access to ArcGIS Online, everything that he's showed is available to you, and much, much more. It's all part of your subscription, so do check it out. Okay, I'd like to now take some time to walk through the capabilities within ArcGIS. And we're going to make a couple more stops along the way to look at how we can use these capabilities to build and operate digital twins at some of the different levels of maturity. So let's start with mapping and visualization. We've already seen so much of this in action today. Mapping is how we convey spatial information to one another. I like to think of it as the language of geography. And we saw Finn mapping objects, locations, where things are, and beginning to look at patterns and interactions and how one object relates to another. So ArcGIS provides us with a rich suite of capabilities to be able to do these things. We've also talked quite a bit about spatial analysis today. It's about extracting knowledge and uncovering patterns using geography, and it underpins the analytical digital twin. Now, spatial analysis is available across the whole of the ArcGIS system. For example, one of the advancements we've made recently is to release a new set of analysis tools within the new ArcGIS Online map viewer. And what we're seeing is the areas of spatial analysis and data science continue to converge, and that's a trend which I expect to accelerate, particularly with all the rapid advancements that we're seeing in the area of AI. Now, speaking of AI, spatial machine learning is where we can train models to intelligently classify data and to make predictions. And then we can use these trained algorithms to automate the extraction of information from sensor data. And it's also these techniques that underpin real-time and autonomous digital twins. Now, many of these models and techniques are available for you to use, shrink-wrapped, ready to go in the Living Atlas. And we've also recently released a new Geo AI toolbox in ArcGIS Pro, which allows you to use and train AI models using machine learning and deep learning techniques. We've integrated graph data with ArcGIS. ArcGIS Knowledge puts a graph database inside the ArcGIS system, which allows us then to take advantage of graph analytics, which helps us model how entities are connected and explore the relationships between them. And in the latest versions of Pro and Enterprise, you can connect out to an external graph database and leverage your existing graph datasets as well. We also have tools to address the spatial analysis of big data. And ArcGIS Geoanalytics Engine takes the power of ArcGIS and it points it directly towards your existing Spark environments. So lots of stuff going on in spatial analytics. It's a broad and capable ecosystem in its own right. Let's move on and look at another area, field operations. So this is where we have our comprehensive ArcGIS Field Maps application. It's useful for visualizing and collecting data. It works online and offline with sync. You can do location sharing. It's really designed to support a distributed mobile workforce at scale. We also have Collector for your forms-based approaches, and ArcGIS Quick Capture, which has been specifically designed to suit collecting rapid sets of observations. And we're going to see support for ArcGIS Field Maps coming to Windows 11 this year through the Windows subsystem for Android. Data management and editing is about modeling the relationships, the attributes, and the behaviors of data within different contexts. So let me give you an example. We've built Utility Network to accurately model the utility environment. It's really good at modeling equipment, connectivity, flow, tracing. Equally, we've built the rules and the behaviors to model information in other environments like roads, hydrology, pipelines, indoor mapping. And you can imagine if we can model each of these environments and contexts accurately in their individual nature, we can then bring them together to enrich and hydrate our macro digital twin environment. And because each of these environments is based on services, we can work with them through browsers and mobile devices, as well as with traditional desktop clients like ArcGIS Pro. So now I'd like to introduce you to Claire Williams. Claire is our product comms manager, and she's going to be looking at how we use spatial analysis, field operations, data management, editing to build and operate the analytical digital twin. Claire.
Thanks, Mark, and good morning. For the next 10 minutes, I'm going to progress the digital twin that Finn started earlier by focusing on these key elements: adding our own organisation's data to add context, collecting new data in the field to build on what we already know, and then bring this all together to help us make decisions. And I'll do this by looking at how we can use ArcGIS Online to help us reach our organisation's biodiversity targets. Before I get started, though, could I have a show of hands who's heard of Biodiversity Net Gain? Excellent, thank you. That's a really good number of us here in the main plenary room, and I'm sure a few more joining us online. But just so that we're all on the same page, Biodiversity Net Gain is a strategy that ensures the habitat for wildlife is in a better state than it was before any development takes place. And this is important for a few reasons. Not only for the benefit of our natural environment, but also because soon developments in England will be legislated to prove at least a 10% increase in biodiversity. And this responsibility lies with landowners, managers, developers, and so on. Of course, many organisations are responsible for land. However, it might be surprising to you, because it certainly was to me, to learn how much land a water company manages. This is the extent of the land managed by just one water company, Anglian Water, who I'd like to thank for collaborating with us on this session. These land parcels represent 71 square kilometres of land, and just to give that some context, that's the equivalent of just over 272,000 tennis courts. Or, if that doesn't do it for you, it's roughly the size of the nearby city of Nottingham. But this isn't urban land. This is 71 square kilometres of mostly valuable rural land. Do you know how much land your organisation is responsible for? Because knowing this is just the first step. How would you start to understand the quality of that land, capture additional data accurately, and start to plan for improvements? Let me show you how I'd go about it. Back in the digital twin with trees and buildings from the Living Atlas that Finn showed us earlier, I can start to add in my own organisation's data. I've chosen this area because it has a moderate diversity score, making it a good candidate for improvement to help us reach our overall target. I already added the land parcels, but I can also add in any other data that I have. So I've added in some data on a popular walking path. I also have some desktop habitat survey data to add in and understand more about what's on the ground. It seems to be mostly grassland in the hatched orange, with an access road and a building here in the middle. I also have some asset data, so I've symbolised these water mains to show the real-world depth of 1.2 metres below the surface. At this stage, I've enriched this digital twin with our current organisation's data that mimics the real characteristics of this site. But how can we use ArcGIS to not only monitor progress, but to make decisions? I've taken it upon myself to create a little to-do list of a few things I need to do to get there. And I don't think it would be a very good to-do list if I hadn't already done the first thing on there. So I'll check off adding my organisation's data. For creating and editing existing data, let's start by undertaking a full habitat survey. And for this, I'll use ArcGIS field maps. I'm by no means an ecologist, but I'm here recording sightings of some very real nesting goldfinches that will be synced back into ArcGIS Online, either at the time of capture or if I find myself with no network signal later when I return to the office. Field Maps is configured with predefined forms, so I can be confident that the data is in the correct format and ready to use right away. And this is what we can see when we get back to the office, the data we collected with the photo attachments. And we can use this to enhance our digital twin and build up a more detailed picture of the characteristics of this site. Let's quickly revisit our to-do list. What I'm going to show you next combines creating and editing data with making smarter decisions. And for this, I'm using Suite for ArcGIS. Suite is Esri UK's configurable web editing tool that can be used both online and offline and on desktop or in the field. The first thing I want you to know about Suite is that you can define a rule base for whatever schema that you want. I've chosen biodiversity habitats, and I'll aim to increase this biodiversity score while showing you these rules in action. With Suite's topology rules, if I try to add a new habitat in the top right, let's choose a neutral grassland, and I overdraw the boundary, the feature automatically clips to the area of interest, and once placed, the biodiversity score and habitat percentage changes here in real time, so I can instantly see what implications this scenario has. How much this score increases depends on the size of the area drawn and the habitat that I've chosen. And since this is pre-configured, Suite takes care of this, so the user can just focus on testing different scenarios. I'm now looking to this area in the bottom left, and I'm thinking it looks large enough to add a pond. Just simply by drawing a feature, Suite is referencing our organization's data and the configured rule base to let me know that I'm not allowed to place a pond here because it's too close to the public path. Suite is performing intersects and queries in the background to understand the spatial context of each feature's placement and taking into consideration what is being drawn. So whilst I can't place a pond here, I can add an additional neutral grassland. As a user, I can just focus on maximizing the biodiversity potential thanks to this built-in analysis. I'll try again to place a pond here, but now Suite is alerting me that there are nesting birds in this area. And if you remember, this is the data I captured earlier in field maps. But since this is just for information, I can still create this feature. And you'll also notice that when placed, a life buoy and a bench have also been added. This is because I'm using a smart template that details a predefined set of features, but I only have to place one. As a user, Suite allows me to test different scenarios. The real-time feedback ensures I understand the implications of each option, and it guides me the whole time. The rule base ensures a consistency and quality of the data that I'm editing or creating for the first time. And this means that anyone can use Suite, and we can be confident that the data is valid with none of the worries of traditional digitization, so no slivers, no overlaps, and no missing attributes. Planning these enhancements site by site enriches our digital twin by providing new context, creating a complete picture of what land we own, the quality of that land, and how different scenarios can contribute to overall biodiversity net gain. For this particular site, I've increased the biodiversity by adding neutral grasslands and a pond. And just like that, I'm almost through this to-do list. But finally, I want to show you how I'd share and monitor progress with stakeholders. I've used Experience Builder to create an interactive reporting dashboard that we can use to internally check the status of both an individual site, but also look at the land owned as a collective. And we can use this as a tool to find areas that are quick wins for increasing biodiversity, either because they are rated low or because their habitat type is easy to upgrade. This is how I identified the area that we looked at today. And simply by duplicating this Experience Builder and making a few tweaks, I could create a similar app that shares an appropriate level of detail with the public to communicate how these programs of work are improving their local area. One final pit stop to our to-do list. Today, I've shared with you today how I'd enhance a digital twin with my organization's existing data collected in the field using field maps, and how we can use Suite to create and edit data that adheres to best practice and helps us to make informed decisions when scenario planning. And then finally, I shared that information with internal and external stakeholders, and I did this all within ArcGIS Online. Thank you. Back to you, Mark.
Fantastic stuff, wasn't it? Great, Claire, thank you. A real good look there at building an analytical digital twin. Let's move on and look at some more capabilities in ArcGIS. Real-time visualization and analytics is about the tracking, monitoring, and alerting of continuously changing information. Now, sensor networks and IoT are all around us, and integrating real-time data flows is an essential part of the connected digital twin story. In fact, it is one of our maturity levels. All of these applications are based on a network of sensors and devices with either tracking objects that are moving around or stationary objects with changing attributes. ArcGIS is a comprehensive 3D system that is powering digital twins. Now, once again, 3D is accessible across the whole of the system, and it's useful for analysis as well as visualization and increasingly for 3D editing as well. Now, all of this is powered by and underpinned by the 3D object model, which is based on the I3S OGC standard. And one of the areas of focus for us recently has been integrating real geography with game engines. These are immersive environments that are not just for games developers, but increasingly model and simulate our world with access to things like physics engines, weather and lighting effects, visualization, and animation capabilities. So you can see how well that blends with the digital twin story. So we now have ArcGIS Maps SDKs for Unreal and Unity game engines. We've seen an explosion of interest in the imagery community, with remote sensing increasingly autonomous, which is generating information products that represent and monitor our environment and track change. Now, ArcGIS allows us to visualize, analyze, and share these information products, and it also supports map and data production, as well as the management of all types and formats of imagery at very high volumes. Now, this is a rapidly expanding area which is being democratized by the access to data collection techniques. Things like tasking drones and satellites is becoming a commodity service. LiDAR sensors are in mobile phones. So what we're seeing is the availability and the variety of these types of information products is just increasing rapidly. Lots of our partners are doing really important work in this space, and we're going to see some of that in action shortly. And because of this, we've put a lot of investment into the area of reality capture, which takes 3D and imagery and fuses them together and uses photogrammetric processing to create information products like point clouds, digital surface models, true orthos, and meshes. Now, in this space, for many years now, we've had drone to map and site scan to be able to process that raw data into those information products. But over the last few months, we've also released ArcGIS Reality, which is about taking these existing approaches and applying them to operate at scale over very large areas at high resolution, really designed for those aerial mapping and content providers who are supplying the digital twin and the GIS communities. And ArcGIS Reality is available in 2 flavors. You can get it as an extension to ArcGIS Pro, as well as a standalone ArcGIS Reality Studio. So this is a great opportunity for me to hand over to Claudia. Claudia Hodgson is a customer success consultant who's working in our product comms team. And she's been looking at how we bring together 3D imagery and reality capture to create these immersive experiences which power connected real-time digital twins. Claudia.
Thanks, Mark. We're going to continue the theme of digital twin, but instead we're now taking a look at imagery. For this story, we're focusing on the hubs of trading. An impressive 95% of world goods are traded by sea, with ports being at the heart of that trading. Much like most other industries across the world, ports are increasingly under pressure to become more sustainable in their operations and must start to more consciously consider net zero targets, operational efficiency, sustainable development, amongst many other challenges. I have been working with Associated British Ports, who are the largest port operator in the UK, with 21 sites across England, Scotland, and Wales, that contributes an impressive 7.5 billion to the UK economy each year. And in February this year, ABP launched their Ready for Tomorrow strategy, which is dedicated to improving the sustainability of their operations. Over the next 10 minutes, we're going to be exploring how using high-resolution imagery can help ABP to run their sites efficiently, but more importantly, sustainably. For today's story, we're heading down south to focus on the UK's #1 export port, Southampton. Here you can see it with the Esri's imagery base map that's readily available in the Living Atlas. And this provides us with a nice representation of the 300 hectares of the site. But as you can see here, this imagery was captured over 2 years ago. So how can we get something more up to date? BlackSky are an Esri partner that specializes in low latency site monitoring from space. Using their tasking application in ArcGIS Online, I can task a satellite to capture imagery over my area of interest. I can specify a time frame and be provided with the number of opportunities for capture. In as little as 90 minutes from that time of capture, I can have the image service delivered directly to my ArcGIS content, ready to be used right across the ArcGIS system. And it can even provide 60-minute revisits, so I can capture a library of images in just 1 day and be provided with a near real-time perspective of the site. How incredible is that? I can stand in front of you guys here, task a satellite to capture imagery over my area of interest, and I get it delivered directly to my ArcGIS content before we all tuck into lunch later today. So I tasked a satellite a few days ago so that we can have a look today. Thankfully, the British weather was kind, and we've got 2 images here. Now, with these frequent revisits and this up-to-date imagery, we can actually monitor the activity of the port. And you'll notice here the smaller vessels and the large container ship entering and exiting the port. With this up-to-date imagery, we can also use it to classify the site, identifying areas of known container storage and parking facilities. And we can even append the capacity of these areas too. But to fully consider how a digital twin can support ABP in becoming more sustainable, we need to take a closer look at the site. And for that, we're in need of higher resolution imagery. The use of drones for capturing imagery is increasing across industries as a cost-effective and efficient way for collecting geospatial data. We have partnered with Hirotech 8, who provide connected drone-in-a-box technology to support round-the-clock automated drone operations. Thanks to their fleet of drones positioned across the UK, we can remotely task a drone already positioned on site to capture imagery over my area of interest, and within minutes, that drone will be in flight. So I tasked a drone a few weeks ago so we can take a look at the data today. To do that, we need to bring these images into the ArcGIS system. Now, as Mark mentioned earlier, ArcGIS Reality is a new photogrammetry software expanding the ortho-mapping capabilities of the ArcGIS system with 2D, 3D, and true ortho product generation. Using the ArcGIS Reality extension for ArcGIS Pro, we can create an ortho mosaic of the site by creating a new reality mapping workspace, naming that workspace, and inputting my drone images. And here we can see the ortho mosaic that's produced. And it really has captured our area of the port brilliantly. We can clearly see all the many containers stacked up on site, the areas dedicated to car parking, or we could even look as closely as spotting these individual units of supplies. So now that we've got this incredible data, let's actually put it to work. At the Port of Southampton, around 14 million tonnes of cargo is handled each year, and it's the UK's leading automotive port with the capability of handling 900,000 units each year. As Finn mentioned earlier, the Living Atlas have a library of deep learning packages for detecting objects within imagery. Using the Detect Objects Using Deep Learning tool that's available in the Image Analyst Toolbox, as well as the newly released Segment Anything model that's now available in the Living Atlas, we can count the number of cars on site to understand port inventory levels. And once we've run that, you'll notice that not only can it detect the number of cars on site, but it can even detect objects that the model's never even been trained on before. such as these individual units of supplies that I mentioned earlier. And with this reality capture method, I've been able to get a near real-time perspective of my site's inventory, and I can even compare it with the known capacity of each of the dedicated parking and storage areas. When tasking the drone, we requested an oblique flight, capturing both images overhead, but also capturing the sides of buildings, allowing us to take a look at our site in 3D. As well as this flight, we also flew over the same area in September last year, allowing us to produce 2 3D meshes using the ArcGIS Reality extension for ArcGIS Pro. With this highly detailed 3D picture of the site, we can actually visually inspect conditions and assess the progress of this construction site. And by linking these 2 3D scenes together, we can compare the area over a 7-month period. And it's safe to say that visually there's been a huge transformation, with a newly constructed container storage area where previously was only building materials. But wouldn't it be great if we could actually take this one step further and quantify this change? Using ArcGIS Pro and its tools available in the 3D Analyst and Image Analyst toolboxes, I've created this model, which is capable of automatically detecting areas of change. It then calculates the volume of that change and can add additional insight to my digital twin. And here on the right-hand side, you'll notice there's been a significant increase in volume, with the increase in containers and the decrease in the salt stockpile over the winter period. With frequent capture facilitated by HeroTech 8's drone-in-a-box technology and a largely automated workflow in ArcGIS Pro, this can become a scalable method for monitoring the site, with little to no impact on day-to-day operations. Another key target for ABP is meeting their net zero by 2040 target, and they're already investing heavily in renewable energy, with 17 of their ports home to renewable projects. Although to fully consider a site's carbon emissions is also critical to monitor the energy efficiency of existing infrastructure on site. Also captured during the drone flight, using this infrared imagery, we can visualize the port in a way that's simply not possible with the human eye, quickly detecting areas that are not effectively storing energy, shown here in the lightest shades of yellow. Now, not only that, but we can actually inspect individual windows and doors with this 3D infrared. Now, these are just a few use cases of using drone imagery. ABP themselves are already testing the use of drones for carrying out automated, beyond visual line of sight missions as part of their Future Flight Challenge program. So let's reflect on what we've seen. Stood in front of you today, we've tasked a commercial satellite to capture images over the port of Southampton, and I've had those images delivered directly to our ArcGIS content. We've autonomously flown a drone over the site for a highly accurate digital representation in 2D and 3D. And we've examined that imagery using the analytical tools available in the ArcGIS system. And this really is just the beginning. These reality capture technologies can be harnessed to regularly resurvey the site, providing a near real-time perspective in a completely automated workflow. Ultimately, this can help organizations such as ABP to develop a real-time digital twin, providing them and improving the efficiency, but most importantly, the sustainability of their operations. Thank you. Back to you, Mark.
Thanks, Claudia. So much going on there, wasn't there? Stunning imagery, powerful analytics, integrating near real-time workflows, and also starting to touch on some of that autonomous activity as well. Great stuff. Thanks, Claudia. Okay, so we've covered lots of ground this morning looking at how we can use the capabilities of ArcGIS to build and operate digital twins. But one question that you still might have for me is, well, how do I access those capabilities if I want to get started? What do I actually do? Well, at Esri, we wrap capabilities into products and apps that are specifically suited to support different types of work. And then we bring those products together in the ArcGIS system, which is comprised of 4 pillars. Let me walk you through them. The first one is a desktop software pillar, where we have ArcGIS Pro and other professional desktop tools. Pro is our spatial analysis and data science workstation. It's been specifically designed to work with local data, to connect to ArcGIS Enterprise, ArcGIS Online, and work with OGC services. Next, we have our server software pillar, where we have ArcGIS Enterprise, GIS infrastructure for your organization. You can install it on premises, you can run it in the cloud, and it comes with all of the capabilities that we've talked through today. We're also seeing increased interest in ArcGIS Enterprise on Kubernetes, which is a cloud-native deployment option that sits alongside our existing deployment options on Windows and Linux to provide more flexibility. It's highly scalable, there's lots of strong DevOps support, and it also comes with a new business model, which is based on users rather than cores, which gives you some of that scaling agility. Next, we have our software as a service, or SaaS pillar, where we have ArcGIS Online, the world's largest mapping and data sharing ecosystem. We're actively providing capabilities into software as a service because it simplifies access for people and it makes GIS accessible to a broader audience at a simpler point of entry. And today, you'll find many, many of the capabilities that we talked through available as SaaS. And then we have our PaaS platform as a service pillar, ArcGIS Platform, which takes everything that we have and it addresses the needs of developers by providing access to ArcGIS through an API. And that comes with a simple, clean, consumption-based business model as well. And then at the heart of all of this, we have a portal. The portal is really what brings together ArcGIS as a system. It centralizes everything. It provides us with some of those centralized capabilities which are so powerful, but we all take for granted. Things like identity, security, content management, secure sharing, and collaboration. Now, there's a portal in ArcGIS Online. There's a portal in Enterprise. You can connect to it with Pro. You can build apps for it with ArcGIS Platform. And you can leverage capabilities from it, such as identity and sharing, for example. It really is the heart of the ArcGIS system. So there we have it, ArcGIS. It's a set of rich and powerful capabilities that are accessible on premises, online via SaaS, in the cloud, or via an API, and curated into powerful applications by us at Esri, by our partners, and by you, our users, our community. You're the people who really bring all of this to life. So, welcome to the conference. Welcome to ArcGIS 2023. I'm delighted that you're here. I'm really looking forward to meeting and speaking with many of you throughout the day. So have a great day with us. Thank you.